Hi, so today we're going to be making this cool Starry Night simulator using JavaScript and more specifically Paper.js and PaperScript. So it's very simple. These are 4,000 randomly generated points. It loops back to the start so there's no memory usage. And you can speed it up and slow it down using the keys. And I know it's not perfect, but it works and it gives that really cool 3D depth effect. So on top of that, there's also random color generation based on actually chance. So it's not completely random, and you can see that there's a lesser chance of a blue star being formed than a white star being formed. So I'm going to go over all of this in this video and how to create it from scratch. So first of all, I'm going to, in this section, set up the file and the folder and link all of the libraries so we can use them. So first of all, open Sublime Text, or whatever text editor you're using. And the first thing you want to do is in the head, link your library. So if you don't already have Paper downloaded, you can just go to paper.js.org and download it. So it's in the download section, quite easy. I'm not going to go through that in this video. So what you're going to do is you are going to link the library. So all we're going to do is in the head section, we are going to create a script tag. I just typed out script and then click tab. And then after that, we are going to set its source to the directory of the library. So I'm going to do /, and then we're just going to follow the pattern. So assets, and then JS, lib, and then paper full.js. So there we go. Now we have we have the Paper.js library linked. So now why don't we go ahead and set up our paper script. So if you're not familiar with Paper.js, it does not actually use normal arbitrary JavaScript. It uses something called PaperScript, which is, it allows you to use multipliers and math operators in vector graphics. So it's very easy. What you're going to do is right below the library, I'm going to type out script. And instead of text/JavaScript, we're going to do text/PaperScript. So this doesn't make that big of a difference because it's, again, just using the mathematical operators so that you can use it in vector graphics. But one small difference you'll notice is that if you're using Sublime Text, none of the keywords are highlighted or any colors like that. And that's because it's not very widely used and known. And one thing before I'd like to go on is you can actually console log things in Paper.js, and you can view them in the Chrome Developer Console, but you cannot access anything. So I'll show you right here. If I define a variable and set that to 0, if I go into the project, open it, and let's open the Developer Console, and if I try to view you can see it says it's not defined. And that's because Chrome does not recognize PaperScript. So you need to keep this in mind when you're looking at debugging. What you have to do is sort of console log things in the script and then it'll work, but you can't actually access it from the console. So yeah, that's really it before we go on. And one thing I'd like to say, if you're not comfortable with JavaScript or HTML and CSS, this may be a little bit hard, but I'm trying to explain it the best I can. If you're familiar with it, that will be very helpful because I'm going to go over some topics quite quickly. And if you're not familiar with it, it may be a little bit hard to understand. Okay, let's continue. So the first thing I want to do is set up my canvas. So I'm going to go down to the body and create a new canvas. And then I'm going to give it an ID of my canvas. So there we go. And also I have my CSS, but I'll do that later. And if we refresh, obviously we can't see anything because, we don't have it linked. So why don't we go ahead and do that? Also, if I open up the console, you can see it says unable to find canvas with ID null. And that's what we have to do now is link it to paper. So we're going to open this up. And in here, we are going to say we're going to say canvas and set that as an attribute for the PaperScript script. And then we're going to set that to the ID of the canvas. So my canvas. Now if we go ahead and refresh, there we go. That error message is gone. So now the canvas is linked. So the next thing I want to do is link our CSS so that we can set up the canvas for the for the page. So what I'm going to do is create a link tag. So type out link and then click tab if you're in Sublime. And then at the href, I'm going to again set the directory. So dot/assets/css/style.css. There we go. Now we have our CSS linked. And just, for some testing in our CSS, I'm going to set the background to red. So let's go check that out now. All right, there we go. The background's red. Yes, I know this may be a little bit distracting. All right, let's get back to it. So now that we have that linked and working, we can start working on setting the canvas. So the first thing I want to do is set the body and HTML to a height of 100% and give them 0 margin and padding. So what this does actually is allows the canvas, which we're going to set to take up the full screen, to actually take up the full screen without any white space. So first thing we're going to do is we're going to set the height and width to 100%. So height 100%. Actually, you know what? We don't need to set the width to 100% because it just works like that. You don't need to actually set the width because the canvas already takes up that space. So once we've done that, we're going to give it no margin. So a margin of 0, and we're going to give it no padding. Okay, there we go. Now we have our body and our HTML set up. Let's go ahead and refresh. And now we are going to go ahead and set the canvas up. So I'm going to make a new line and then select the canvas with an element selector because there's not going to be actually much HTML on the page. And let's give that a background of black for first, just to see what it looks like. Sorry. Black. Then refresh. And there we go. There's our tiny little canvas on the screen. So now let's set that to be full width. So this is quite easy. All you have to do is go width and height to 100%. Width 100%, and then a height of 100%. Now if we refresh, there we go, our canvas takes up the full width. So why don't we continue? Let's go back to our project, and now this is all the HTML and CSS that we're doing. So we're going to move right into JavaScript now. So, by the way, if you have watched the whole thing, congratulations. But if you want to skip ahead to parts you just want to see them, I have listed all of the timestamps for each section in the description. So just go there and click on the timestamp and it'll take you to that section. All right, let's start. So the first thing I want to do is generate the stars onto this canvas or this page. So what I'm going to do is loop through about 4,000 times. I'm going to have a stars array, and then each time it generates a random point on the page, creates a circle, and we're going to have it with a set radius for now. But in the future, we're going to make that random. But we're going to have a set radius for now, and then we're going to fill that with a white background to make it look like a star. So why don't we go ahead and do that? So in our paper script, we are going to create a new variable with the keyword var, and we're going to call that stars. And then we're going to set that to an empty array using these square brackets. All right, so now we're going to go to a new line and we are going to create a for loop. So we're going to set var I, and we're going to set that equal to 0. And then we're going to set I is less than or equals to the number of stars we want to generate. So I'm just going to go around 4,000 here. And then of course increment it with I++, curly brackets. And now we can start creating. So firstly, what I want to do is in the first loop through, or in every loop through, it's going to generate a new path, that's a circle. And then we are going to fill that with a white color. So why don't we go ahead and do that? So I'm going to say var circle is equal to new path.circle, because that is the syntax for creating a circle in PaperScript. So we're going to set that to a variable. And now the path.circle takes 2 arguments. It takes the point, and then it takes the radius of the circle. And this doesn't actually set the color. It just sets the circle itself. So we're going to set this to a random point on the page. So we want this page to be responsive, so I'm going to use some really clever syntax over here. So first of all, we're going to create a new point, which is the syntax for creating a new point in PaperScript. So new point, and then it's going to take an X and a Y, or a width and a height. So there's this really cool object, or this really cool method and object. It's called view.size, and this will actually take the view, the height and the width of the device that you're currently on, the maximum, and you can actually use that and it'll take the maximum from every device. So after that, we grab it and then we set a random point from that. So obviously in here, there is a width value and then there's a height value. So in the width value, I'm going to set it to view.size.width, and then I'm going to set it to view.size.height. So this takes the maximum width and the maximum height, and then again we're going to use the math operators in PaperScript and use this really cool method called point.random. So what this does is generates a random point from here. So there we go, and now it'll put this center of this new circle at a random point, and then let's just for now set the radius to 5. Because we're going to go over random size generation later, but for now let's just actually, you know what, let's set it to 1 for time's sake, and just so you can see all the stars. So we're going to set it to 1, and now if I actually go ahead and refresh the page, you can see we can't see anything. Now these points are generated, but they don't have any color and they don't have any sort of substance. So first thing before we go on is we want to push this into the stars array, because in the future we're going to need to loop through to do things and to do and manipulate these stars. So the thing how PaperScript works, if you don't sort of manipulate it and put it somewhere, you are never going to be able to access it again. So for example, if you create a new circle and you don't save it to a variable, you cannot manipulate that circle or change it or do anything with it. So that's what we're going to do. We're going to use an array method to store all of the stars. So what we're going to do is say stars.push, the .push method of every array, and then we're going to say circle. So there we go. But we still have one final thing to do, and that's actually set the fill color, because you can see we can't see the stars. So there is this cool method in Paper.js where you can set the fill color using circle, or the object name, .fill color. And then we're going to set that equal to, make sure it's in quotations, to white. And now refresh, and you can see we have all of our stars. So there we go. And you know, if we refresh every time, they're going to be generated at a random point. And obviously, they cannot go off the page because I set it to the maximum height and width. And if I actually sort of close this out over here, make it smaller and refresh, you can see it still stays within. So this is a really cool feature, and it will stay like this. So now that we have our point generation working, let's move on to animation. Okay, so for animation in Paper.js, there is a function called onFrame. So what this does is every frame it will do something. So the way to do this is you just type out function onFrame, and then in brackets you take event as an argument, which is sort of the event that's been going on. So we won't be using the event in this function, but we will use it in the Keypress function, which I'll be talking about later. So in this function, anything we put in here will be run every single frame. So this could be 60, 100, 5, it doesn't really matter. But the point is, this is how we're going to do animation, because every frame is going to move 1 pixel. So what we're going to do is, like I was saying before about pushing these circles or the stars into a stars array, we're going to use a for loop. So for var I is equal to 0, and then I is less than stars.length, I plus plus. So this is a very common loop to manipulate things in arrays, especially in the DOM. When you want to manipulate, let's say 100, 1000, 5000 anchor tags, you can simply use this and then address each anchor tag in an array or a list using DOM selectors. But that's for another video. Let's just cover how do we do this. So what we're going to do is first type out stars I. And if you don't know how arrays work, each item in an array has an index. So let me just show you. If I type out the numbers 1, 2, 4, or actually 3, 4, just to make it less confusing, this item has an index of 0. So this would be stars, and then in these brackets, you type 0 to access it. And then this would be index of 1, index 2, index 3, and so on and so on. So this can be applied to every single item in the array. And when I am doing stars I, in each time it accesses the 0 index, so the first star, and then every time it increments, wait, I forgot to add an H there. Every time it increments, it's going to move up one index. So the first star, the second, the third, the fourth, all the way up to stars.length. And one thing to note, stars.length, or the length of any array, is always going to be one more than the number of indexes. So for example, if the maximum index in an array was 6, the length would be 7. So when I say less than here, the loop would stop when it reaches one more than the maximum index. So that's enough for arrays. Why don't we actually get in? So Paper.js has a function, or a method actually, called translate, which lets you move something. So let me show you. And then of course it takes two arguments. It takes a width and a height. So it moves by a width and it moves by a height. So we're going to set the height to 0 because we only want it to move sideways. And then we are going to set this to 1. But let me just show you something here. We have whoa, got an error. Okay, so there is a small bug, but it will go away once I go over the solution. So the thing is, what we're actually doing now is we are translating all of the stars at the same rate. So we're just going to move. It's going to look just like a moving canvas, and it's not actually going to give that cool star moving effect. So the way we do this is actually loop through all the stars and give them an assigned random rate between one or so numbers, right? And what we want to do with that is assign the rates, or using this loop in the onFrame event, and translate each one by its assigned rate. So I'll just cover it, and I know this may sound a little bit confusing now, so why don't we just go ahead and cover it. So right under this for loop, we're going to write a new one. So for var I is equal to 0. It's the same syntax as the one below, I++. And then what we're going to do is say var assigned rate is equal to math.random. And if you don't know what this is, what it is basically a random number between 0 and 1. So 0.567, blah, 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 it goes on and on. It generates a random number. And then first thing I want to show you is, because we're going to be using this later on, I'm going to create a new velocity variable. Oh, one thing I forgot is I need to erase those 1, 2, 3, 4 in there. So if I go ahead and refresh, you can see it is fixed. But you can see it moves like a blank canvas. So that's a big problem, and that's what I'm here to fix. So let's go ahead and refresh that. So we're going to create a new math.random, and then we are going to times it by the velocity. So I'm going to create a new variable called var velocity, and then we're going to set that equal to 2. So what this does, when I times it by velocity, let's say the number is 0.5. You times that by 2, and that would give you the velocity of the specific star. So after that, we're going to say stars I dot rate, and remember, because this circle is actually an object, we can add things to it using the dot and then whatever you want here. Dot rate is equal to assigned rate, right? So this will loop through and give each one an assigned rate. But one thing we need to do now is translate it by that assigned rate. So what we need to do, instead of having it 3, we're going to say stars I, or the specific index dot translate stars I dot rate. So because it's the exact same index, this is star0.rate is equal to its rate, this will translate star0 by its rate. So if this sounds a little bit confusing, I'll just summarize it up for you. We loop through, we give each star an assigned movement speed, and then each frame, it moves each star by its assigned movement speed. So now if we go ahead and refresh, you can see it gives that cool 3D effect now. And the reason we give them assigned rates because if we gave them specific rates, or let me reiterate, if we gave them random rates on each frame, they'd move and be all choppy. And I've actually experimented with this a lot, and I found this is the best method to do it. And obviously you have some that are pretty much near zero, but we'll fix it now. So now that we have our movement set up, that's pretty good and all. But now we want to move on to looping it or moving the stars back, because now they're just flying off the screen. So how do we do that? And that's exactly what I'm going to cover in this section. Alright, so why don't we get started? So what I want to do is basically if the star, we loop through every single frame and we check if the star's width or position of X is past the maximum width, then move it back to the start and vice versa. So this is actually quite easy. What we're going to do is in our file here, we're going to be using actually the same loop because we don't really need to create a new one. And then we're going to say if, using the if and then brackets, if you're not familiar, stars I dot position dot X. So this is the X position is greater than the view.size.width. So this checks if the X position of the star is greater than the maximum width of the screen, then it's going to do something. So what it's going to do is say stars I dot position dot X is equal to 0. So what this does is it basically sets the position to 0 if it's flying off the screen or if it's passed off the screen. So now if we check, you can see that it's constantly looping and it's going back to the start. So also, because we're going to be changing the velocity very soon so that it can actually go that way, we want to check if it's smaller than 0. So on top of that, we're going to use else if. So it checks again, stars I dot position dot X is smaller than 0. So just to give you a little bit of context, this is 0. So if it goes past that, or if it goes under that, so if it goes past, or if it goes under 0, it's going to set its X position to the maximum width. So obviously this won't work now, but I'm going to add key presses, which allows you to change the direction and the speed. So I'm going to be showing that later. So we're just going to write this if statement now so that we can use it later. So if it's under 0, if the position is under 0, then we're going to say stars I dot position dot X dot X is equal to view.size.width, or the maximum width. And I know I'm missing a lot of semicolons here, so I'm just going to actually include those now. But you get the idea in that it will consistently loop through if it reaches or goes off the screen. So that was quite easy. So you can go ahead and do that. And now that we have that working, why don't we move on to changing the velocity keys? So what we're going to do is use the A and the D keys to either speed up or slow down. And you can even slow it down to the point into the negatives. So why don't we go ahead and do that? So we're going to use a function that is called onKeyDown. So we're going to write function onKeyDown event. Obviously we need the event handler in there. So what this does is every frame, and I know it may seem like we should be putting this in there, but this is its independent handler. So this checks every frame if a key is pressed, and in programming terms, especially JavaScript, key down means when a key is pressed down, and key up means when a key is released. So that's just for you to know. So it checks if a key is pressed down, it's going to run some code. So what we're going to do is we're going to use an if statement to check if the key code is a certain character, and then with that we will speed up or slow down. So what we're going to do is say if, I'm actually going to indent this, if event, so the handler here, dot key is equal to A. So actually we're going to do D to speed it up. So if the key that is pressed is D, then what we're going to do is speed up the velocity. And that's what I was talking about, why we're using a velocity variable. It's because what we want to do is actually sort of manipulate it with the A and D keys instead of just using a standard number. So instead of using math.random times 2, we're using times velocity because we're going to change this. So what we're going to do is do velocity plus equals 1. So this just means velocity is equal to velocity plus 1. So this is the same as velocity is equal to velocity plus 1, for those of you that don't know. So it adds 1 to itself. And then because this only runs once, we're going to need to run this again. But what I'm actually going to do is, just to clean things up, I'm going to create a new function called assign rate. And if you don't know how functions work, use the function keyword, type out the name, use these brackets to indicate it's a function, and then some curly braces, put everything you want inside there. So this is just to clean things up a little bit because we're going to be using this multiple times. And then we're just going to run the function assign rate. So it's going to add 1 to velocity, and then it's going to assign it using the times of the current velocity. So although this is a random number, it's between 0 and 1. And the velocity, because you're multiplying it by, it impacts the magnitude of the speed. So this will work. And now if we actually go ahead and check and try speeding it up, you can see that it does speed up. And I know you may, if you focus on 1 star, the speed is constantly varying. And that's because, again, you're using a random number. But we still have one small problem. And that is, you can see at the beginning here, it's static. So we need to fix this right away because you don't want people, clicking, not knowing what keys to click, if you're ever going to put this into real world, which you're probably not. But it's still a problem we need to fix, so why don't we go ahead and do that now. So this is actually quite easy, and if you don't know a lot about functions, basically, when you're defining a function, you do not actually run it. So we want to run this right after so that we can actually assign the rates so that we can move the particles or the stars. So what we're going to do is just on a new line, type out assign rate to call the function to run the function. So now if we go, let me just put a line here because I like my code to be neat. And if we go ahead and refresh, there we go. So if we go ahead and refresh, there we go, it's working again. And we can speed it up. And of course it moves back to the start. So I also tried another method, which is deleting it when it gets to the end and then generating a new one. But eventually this does not work because if you speed it up fast enough, the generation cannot keep up because the generation is set as a fixed rate. So you can see I can go pretty much as fast as I want, but there are obviously some glitches, but this is the best we can do with what we're working with. Okay, so now we want to add the event key for going backwards. So it's pretty simple. I'm just actually going to copy this, and instead of adding 1, it's just going to subtract 1. So it's going to do minus equals 1, which subtracts 1 from itself. So it's going to slow down and, assign the rates again. So you can see I can slow it down, and it will eventually even go into the negatives because it's subtracting 1 from itself every time. And that is why I made it so that if it's under 0, it goes to the maximum width, is so that it works from this side as well. Okay, so there we go. And now we have our movement and our velocity set. So now we're going to move on to some of the fun stuff, which is random size and color generation. So this is actually fairly simple. The first thing we want to do is generate the stars at random sizes. So I'm actually going to go to my original code here and steal this. And I'm going to be honest, I just found this on Stack Overflow. But what it does is it's much better than math.random in the sense that you can use this function to generate a random number with a minimum and a maximum. So this is quite cool. And we're going to use this to set our radius. So instead of using a set radius of 1, we're going to call random int with a minimum of 0.5 and a maximum of 2. Now if we go ahead and refresh, you can see this already looks a lot better than what we had before. So now we're going to go to random color generation. So I was talking about this before, and it is actually quite perplexing when it comes to chance, but it is quite simple when you think about it. So with math.random, there is one way to generate randomly, and that's creating an array and then choosing a random number to set the index of that array. So it would choose a random number from 0 to 3 and then set that number as the index. And it's quite complicated and long, but that's also a way. But we want this to be based on chance. So let's say there's a 70% chance of getting a white star, 30% of a yellow star, 5% of a blue. And we're going to be doing that all. So this is quite simple. What we're going to do is loop through. And what we're going to do is then generate a random number. And then if that random number is bigger than or smaller than a certain number, which is going to be our percentage or our chance, set it to this or do this. So what we're going to do is, just to clean things up, I'm going to create a new loop. And I know this is quite inefficient, but I want to separate the creation and the color setting or generation. Don't ask me why. It is quite heavy on performance, but I'm going to do it my way. If you want to combine these loops, or instead of writing 2, just put it all in one, go ahead. But I want to do it like this. Alright, so we're going to say var chance is equal to a math.random. So a random number between 0 and 1. And then we're going to say if the chance is smaller than 0.7, right? If the chance is smaller than 0.7, so that's 70% of the time, we are going to set stars I dot fill color, and then for now we're just going to set it to white. And let me indent this properly. And we're going to say else if chance. And there is one small problem with this order, but I'll get to that later. 0.3. We are going to set stars I dot fill color equal to blue, or actually yellow. But I'm going to actually make this 0.29 because I want there to be 1% of the chance of the time getting a blue star. So else if chance is smaller than 0.01, we're going to set stars I dot fill color to blue. So this is a pretty common method when it comes to generating things by chance. So you generate a random number. If it's bigger or smaller than this, do this. And the number is the percentage. So stars I dot fill color is equal to blue. Okay, so there we go. We have our color generation set up, but there's still one small problem. And if we refresh, you can see we only get white stars. And that is because, first of all, we didn't erase this line. But there's a bigger flaw that I'd like to point out. Is that the way if works is that if it's smaller than 0.7, it does this and it ignores the rest. So, for example, if it was 0.7, it would set the color, but it would not read this. Now, there are multiple ways to do this. You can just erase the else if so it's not chained together, and it checks each one, and it will override the color. You can do that, and that would work perfectly fine. You can see we have our very bright and vibrant colors, but also you can rearrange the method to go from smallest to biggest. I would recommend this one, just not linking with else if, just using normal if statements, because the way that this works is else if is connected to the first if. So for example, if the first if isn't fulfilled, so if the condition is false, then it checks the next one. Whereas this one, let's just say the number is 0.01, all right? When it comes to this, it's smaller than 0.7, yes, then set it to white. And where it comes to else if we had else if here, it ignores the rest, because if the first condition is true, or if one condition is true, it ignores the rest. It ignores anything under it. Whereas this, it will check each one individually because they're not chained together. So it's 0.01. So the fill color is white now, right? It checks if the chance is, now it actually checks if the chance is smaller than 0.29, which it is, it sets it to yellow. So it overrides the white. And then if it's smaller than 0.01, or actually we should say, if it's smaller than 0.01, it would set stars I.fill color equal to blue. So obviously this should be less than or equals, and I was going to point that out because the way less than works is that if it's the same, it won't work. So you need to put less than or equals. So if it's less than or is it equal to? So that'll make sure that it's all correct. And then now if we refresh, there we go. So that works perfectly. And really the only thing we can do now is actually just change our colors here. So, change them to some hexadecimal or something that looks a little bit more neat. But that's not really important, and I don't really want to do that now. But there we go. All of the functionality is working. Color generation, size, looping. It's all working and ready. So thank you so much. If you actually want to download the project, this version of the project, the better looking one, all you have to do is go to the description of this video. I've uploaded it onto Mediafire or whatever site I decided to upload it after this video. But you can go ahead and download this and play around with it as you want. If you have any questions or you're confused with something, just leave a comment and I'll try to fix it for you or respond to you. And again, any questions, leave it below. All right, thanks for watching and I hope you enjoyed.